for the invite, and thanks very much for this really nice workshop. I had to miss the first day because my train was canceled, but I still think it was really nice so far. So yeah, big thanks to the organizers. All right, so today I want to talk about rational aversion to information. And in particular, I want to talk about the following question. Is it always instrumentally better to have more information? So the more precise way I want to understand this question is like, if you have the opportunity to either make a decision now or wait for some more information and make a decision then after learning, what should you do? All right, and so here's an example just to sort of like get your intuitions going. So imagine you're at the race track, you know, and you're about to bet on a horse. It's like a horse race and you're deciding which horse do I want to bet on. And you know, you're just about to place your bet, but then this like sort of charming stranger comes up to you and is like, well, you want to hear what I think about the horse race. And you can decide to either ignore the stranger and be like, no, I already know what I want to do, place your bet. Or you can listen to the stranger and then afterwards place your bet. And the question is, what should you do? All right. So think about that. Cool. So to sort of address this question, I'm going to use a framework of Bayesian decision theory, very fitting for the occasion of the workshop. And I'm going to use a framework where we have a set of states of the world, omega, a set of outcomes, fancy O, and a set of actions. And I'm going to think of actions as functions that map states of the world to outcomes. And so that's kind of the framework of decision theory inspired by Savage. And so this is like the sort of basic ontology. And then we're going to think of our agent as equipped with a probability function on the state space. So that's going to be our model of beliefs, Bayesian beliefs, and a utility function on the space of outcomes. All right, and then we're going to think of a choice situation as a set of actions. So all of that is kind of abstract, so let me map it back to our initial example. So in the horse race example, this probability function P might model your credences about which horse is likely to win, and what's the stranger going to say, and other events that might be relevant. And the utility function U might model how you value the outcome of the bets under consideration, for example, money, or whatever else you can win at the horse track, I don't know. And S, this choice situation, could be a set of all the bets that are on offer. Not necessarily all the possible bets, just the ones that are on offer, and you sort of have to make your choice among those. All right, cool. And then we have this bit of standard sort of Bayesian advice, which says that if you are confronted with a choice situation, you should maximize expected utility relative to your probability function P and your utility function U. So you should take one of the actions in the choice set that maximizes expected value, which is just defined as here. And in this example, it might be that this advice says you should take the bet with the highest expected monetary payoff, because you really care about money for some reason. Okay, good. So that's our basic decision theory framework. But I'm also going to be interested in learning. And so I have to say a little bit about how I think about learning for the purpose of this talk. So I'm going to model learning as there is a partition of your state space, and you're going to learn exactly one element of this partition, the true element. And I'm going to assume that this evidence partition consists of events that all have non-zero probability. And I'm going to write P conditional on fancy E to denote your credences, which are updated on this evidence partition. All right, so that's just a bit of bookkeeping. And one thing that's going to be kind of really important for what I'm going to talk about is the notion of information or learning being cost-free. So when I say that information is cost-free, what I mean is that learning the information doesn't change the choice situation that you're faced with or your utility function. It only changes your credences. And let's map all of this back to our initial example. So in this example, it might be that the evidence partition is just all the things the stranger could say. And plausibly, that's cost-free, because it wouldn't change what bets are on offer at the horse track, and it wouldn't change how you value the outcome of those bets. It would only possibly change your credences. All right, so that's cost-free learning. Cool. All right, so remember our initial question. Is more information always instrumentally better? If we have the choice between acting now and waiting and acting then, what should we do? So I want to talk about this very famous and influential argument by Good, which says that the answer is yes, more information always is instrumentally better. If we have the choice between acting now and learning some cost-free information and acting later, we should always do the latter. We should always learn. All right, and here's Good's argument in my reconstruction. First premise, rational agents should maximize expected utility. Second premise, if you think about it, the expected utility of first learning some cost-free information and choosing afterwards is always greater than or equal to the expected utility of choosing now. I'm going to talk about the second premise in a bit more detail because it's not obvious. So here's how Good tries to convince us that the second premise is true. So let's consider any choice situation. Just think of the different bets that you might take at the horse track. So you're faced with the choice of either placing your bet now or learning what the stranger says and placing your bet afterwards. And so let's just think through those possibilities. So what happens if you choose now? Well, in this case, you're just going to take the bet or one of the bets with maximal expected value relative to your current credences. That's just what the norm of maximizing expected utility says. All right. And let's think about what happens if you choose after learning. So the way Good thinks about this is as follows. So when you learn the true element of this evidence partition, you're going to update your credence on that event by Bayesian conditioning. I'm going to have a lot to say about that in a second. So you're going to update your credences in the Bayesian way. And then you're going to choose an action that maximizes expected utility relative to your updated credences. And so we don't really know, so the thing that I marked here, we don't really know what that is yet, because you don't know which event you're going to learn. But you can consider the expected value of taking the best action according to your updated credences. And then Good just proves this like simple mathematical result, which is this inequality, which says that the expected value of first updating your credences and then choosing the best action according to your updated credences is always greater than or equal to the expected value of acting now. And Good says, okay, here we go. The philosophical upshot of this result is that rational agents are always permitted to accept free information before making a decision. And we can actually strengthen the result a little bit. So if we say not only that the information is cost-free, so it doesn't change the choice situation, but also that the information is possibly relevant. And what that means here is just that at least one bit of information will make you do something different than you wanted to do initially. So that's what I mean when I say that information is relevant. We get the result that this inequality is actually strict. So the expected value of first learning and then acting according to your updated credences is strictly bigger than the expected value of acting now. And so Good says, here we go. The principle of maximizing expected utility entails value of learning. And value of learning is just how I label the claim that first, rational agents are always permitted to accept cost-free information. And second, rational agents are actually required to accept information that's both free and relevant. All right, so that's value of learning. Good. So let that just sink in for a second. So here's what I want to do today. So I will actually agree, at least for the sake of argument, with Good's first premise. I will agree that rational agents really do or should always maximize expected utility. And let me just point out that that is kind of very significant in the present context, because it's like well known in the literature that if you disagree with this premise, value of information or value of learning turns out to be false. So many alternative decision theories, alternatives to standard expected utility theory, do not say that rational agents are always permitted to accept cost-free information. And that has actually often been taken to be a problem. And I'm going to have something to say about that later. And implicit in premise one is also the assumption that our agents actually have precise credences. And it's also pretty well known that if you go for imprecise credences, value of learning is going to turn out to be false. And the same can be said for the assumption that information partitions logical space. So what I want to do today is basically say, people have pointed out that if we relax these assumptions, value of learning turns out to be false. But I actually think these assumptions are good, and I'm going to take them on board. But I will disagree with Good's second premise. I will say that the way Good thinks about the expected utility of learning cost-free information is actually kind of problematic, and there's a very strong hidden assumption. And so it's just not true that the expected utility of learning cost-free information and choosing afterwards is always greater than or equal to the expected utility of choosing now. So basically my main goal for today is to convince you that the principle of maximizing expected utility actually does not entail value of learning. All right. So I hope that lays out a nice roadmap for the rest of the talk. And now let's get into the argument. So why is premise 2 false? Here's why, in a nutshell. So I already sort of like hinted at that when I explained Good's reasoning, but the way Good thinks about the value of first learning something and then choosing afterwards is really in a way where he presupposes that you are certain that you will update by conditioning. You're not certain what evidence you will receive. There's like this whole partition of things you might learn, but you are certain that whatever it is that you will learn, your response to learning that evidence will be Bayesian conditionalization on the evidence you have learned. And I want to convince you now that that is actually implausible. We should not be immodest. Instead, we should be modest. We should think that there is at least some positive probability that we will not condition. All right. So here are some reasons for being modest. So first, I think this is kind of a really important conceptual point. So to say that we will condition whatever evidence we'll learn is a sort of like really strong substantive assumption about how our own psychological state will develop in the future. And it's totally consistent to imagine that that turns out to be false. Not conditioning is a totally consistent possibility. And in general, Bayesians have actually thought that consistent possibility should get positive probability. And I think we should kind of say the same thing here. The possibility that we will not condition should get a positive probability. Second, it's not only a consistent possibility, but I think that we do have, or might have, actually good evidence that we sometimes deviate from conditioning. We sometimes like engage in all of these fallacies that people have talked about earlier today, like the gambler's fallacy, or base rate neglect, or overconfidence, and so on. And I think if you know that about humans in general, you should think that this evidence also applies to you. You might actually also be in a situation where you know from your own past experience that you have been prone to non-Bayesian behavior. And that might be an additional, even stronger reason to be modest. Okay, and so I think the really important conceptual point is that the first 2 bullet points here are, I think, totally compatible with being a full-blown Bayesian. You might think, yes, Bayesian conditioning is really the rational way to update. It's what we should do, but it's totally consistent with that to say, well, there's maybe some small probability that we won't do the rational thing. And I'm not giving up Bayesianism and recognizing that possibility. It's rather, I'm following the spirit of Bayesianism. I'm assigning positive probability conditional to consistent possibilities, and I'm assigning probabilities according to my evidence. Okay, the third bullet point is a little different, but maybe still interesting. So perhaps you might not only have the sort of psychological uncertainty about how you will update in the future. Will you be rational? I don't know. Perhaps you might also have this sort of normative uncertainty about whether conditioning is always the only rational way to update. And I think it's, maybe not in a letter, but very much in the spirit of Bayesianism to leave some room for this kind of normative uncertainty. And so that gives you another reason to be modest, even if you're certain that your future self will be rational. All right. So I hope to have convinced you that modesty is a good thing. And now what I want to do is just basically point out that once you're on board with that, once I got you with modesty, then that entails that there are cases where it can be rational to reject free information, instrumentally rational. And what I mean by instrumental rationality here is just maximizing expected utility. So once we have modesty and combine that with the principle of maximizing expected utility, we actually get the norm that sometimes you're better off rejecting free information. All right, so I have two examples here. But since I'm already, yeah, we'll see. Maybe I'm a bit quicker with the second one. Anyway, so here's my first example, the gambler's fallacy example. Okay, so we're going to talk about Anne. And Anne is about to witness two coin flips. And so in her sort of prior state of mind, she thinks that the two coin flips are independent and that the coin is fair. And now what I do is I offer Anne some bets on the second coin flip. So right, there's two coin flips, the first and the second, and she has to decide right now which bet on the second coin flip to take, right? So there's a safe bet, which basically means she doesn't win anything, she doesn't lose anything. There's a risky bet on heads and a risky bet on tails. We're also assuming that Anne values money linearly. She maximizes expected utility now. She's also certain that her future self will maximize expected utility. Just some simplifying assumptions. Good. And so now that I set up this decision problem, I offer Anne a choice between, look, you could commit right now, or you could observe the outcome of the first coin flip and make your choice then. All right. And so the important feature of this example is that Anne is actually modest. So Anne thinks, oh, most of the time I'm Bayesian, right? But there's actually the small probability that I will commit the gambler's fallacy. I know it from my own past. I know it from friends that have fallen prey to this fallacy. So she thinks there's a small but positive probability, epsilon, that after learning that the first flip lands heads, she will become more confident that the next flip will land tails, and vice versa. Okay, and so let's think about this decision problem. So if she makes her decision now, she will pick safe, because that has expected utility 0, and the other two bets have negative expected value. All right. But if Anne learns the outcome of the first coin flip, then there's a small probability that she will do the gambler's fallacy, right? If she does the gambler's fallacy, she will take one of the risky bets, and from a present point of view, that's a bad choice. And so, since Anne can foresee that, she's better off refusing the information contrary to value of learning. And so, note that Anne is like totally an expected utility maximizer. She maximizes expected utility now, she's certain that she will maximize expected utility in the future, and so on. And so I think what this example shows conclusively is that once we admit modesty into the picture, the entailment from expected utility to value of learning just breaks. Rather, expected utility advises agents to sometimes reject free information. All right, but so I've already given this talk sometimes, and people sometimes object to this example and say, look, this example is a little weird because the information isn't really relevant, because Anne thinks that the coin flips are independent, right? And I think there's something to that, right? Even if Anne were certain that she would conditionalize, she would not really prefer learning over not learning. She would just be indifferent. She would say it doesn't matter. And so, well, I think this example shows that Goethe was wrong. I think we can come up with an even better example. And here it is. Here we go. So this is one is a little bit different, and I'm going to call it overconfidence. So again, a coin will be flipped twice, and Anne must decide between several bets. There's a safe one. She could bet on heads. She could bet on tails. She can also take a very risky bet on heads and a very risky bet on tails. That's the setup, right? And in this case, Anne actually does not consider the coin to be fair, but she thinks the coin has a fixed but unknown bias. She doesn't know what the bias is. She has some probability distribution over that. And again, I offer Anne the following options. She can choose right now, or she can observe the first coin flip and choose afterwards. And note that in this example, observing the outcome of the first coin flip is informative, right? It provides some information about the bias of the coin, and that's actually something that Anne would want to know. But again, Anne is modest. She assigns some positive probability, this time not to the gambler's fallacy, but to the possibility of overconfidence. She assigns some positive probability to the event that she will overweigh the evidence. And what I mean by that is, like, when she learns that the first coin flip is heads, she'll be like, oh, it's for sure really biased towards heads. And she will become 0.9 confident that the second coin flip will land heads, and vice versa. If she sees tails, she'll be like, oh, it's for sure tails. And that's not the correct Bayesian response according to her prior, but she thinks there's some probability that she will do it, right? Good. And so let's think about what happens in this example. So if she makes her decision now, she's indifferent between the safe bet, betting on heads, and betting on tails. And so the expected utility of choosing now will be 0, just as in the first example. But if Anne learns the outcome of the first coin flip, there is a chance she will use this information to make a better choice. But there's also a chance she will be overconfident and do something that's, from a present point of view, actually a bad idea. She will sort of overweigh the evidence. Good. And it sort of depends. So here's a picture that I drew of this choice situation. So if she doesn't learn, she will choose safe, expected utility 0. If she learns, what she will choose sort of depends on whether the coin has heads or tails, and whether she's Bayesian or does the overconfidence fallacy. But once we do up this decision tree, we can compute what's the expected value of learning. And here it is. That's the expected value of learning. So it's a function of epsilon. It's a function of what she thinks the probability of overconfidence is. But if you see this expression, you see that if she thinks the probability of overconfidence is high enough, it's more than 1/7 here, then even though the information is relevant and she could really use it, it still turns out that Anne is better off rejecting the information. And so we have another counterexample to value of learning, which I think is kind of even stronger. All right, cool. These examples are basically my main point. Now I'm just going to wrap up and talk about why we should care and what we're learning from this and things of that nature. What do we learn? So I think there's like 2 takeaways. Both are interesting. So first, I think these examples show that value of learning is false. I think they show that in some cases, rational agents can be better off, instrumentally better off, by rejecting free information. And so I think that's interesting, but I mean, people have already argued for that on sort of other grounds, for example, by using like alternative decision theories. I think the very novel thing maybe is value of learning does not follow from the principle of maximizing expected utility. Because remember in my examples, Anne is an expected utility maximizer. As expected utility maximizer as you can be, but still she's better off rejecting free information. Good. And here's another conceptual point. You could ask me about that in Q&A. I'm not going to go into details here, but basically, it turns out that these examples can really be generalized. under sort of plausible additional assumptions, I have this theorem that basically proves that if we consider any modest agent whatsoever, so any agent that thinks there's some probability I will not be Bayesian for whatever reason, I can construct some decision problem in which that agent is better off rejecting free information. So there's this, it's not just like this example and that example, but there's this very general conceptual connection between being modest on the one hand and being averse to information or information avoidant on the other hand. Okay, so this is what we learn. And why should we care? Okay, good was wrong, whatever. So here's, I think, where we should care. So sometimes people give the following argument, sort of in defense of expected utility theory. They say something like this: look, value of learning, the view that you're always better off learning more stuff, it's just obviously true. It's like a piece of common sense. You don't need to do any maths to see that it's just, you just see that it's true. And orthodox expected utility theory can explain this piece of common sense, while other decision theories, such as sort of risk-weighted expected utility theory or decision theories with imprecise predictors, they cannot explain this piece of common sense. And that's actually kind of a reason for sticking with orthodoxy and saying orthodox expected utility theory is great because it can explain this piece of common sense. And so I think we should care about what I'm saying today because we can see that this argument is wrong for two reasons, actually. First, I think it's just not obviously true, or actually not true at all, that value of learning holds. Second, and more interesting, I think even if we're on board with expected utility theory, we actually cannot explain value of learning because we actually recommend agents to sometimes reject free information. Okay, first reason to care. Here's a second reason to care, which I actually think is maybe even more important. So you might also argue as follows. I think this is actually kind of a better argument. You could say, look, value of learning is actually false, obviously. In real life, agents can often have good reasons to reject information. And that's actually a reason to reject orthodox expected utility theory, because orthodox expected utility implies value of learning, implies something false, and therefore it must go. So I think this argument also fails. Once we sort of allow modesty in the picture, we actually get a version of expected utility theory that can convincingly explain why it can be rational to reject free information. And so here's, I think, a really interesting application of that. And from some of the people that are more into psychology, I really want to hear more about that. So I think you can sort of use this model to explain maybe real life cases of information aversion. So there's like a big literature in sort of economics and related disciplines about sort of real life cases where people are information averse. For example, people sometimes avoid medical tests. It's often said that you shouldn't look at your stock portfolio all the time. We also like blind grading and hiring, at least sometimes. And I think once you sort of admit modesty, you can explain these things as rational. You can basically say, look, the reason why we're sometimes better off knowing less is because there's this possibility that we make what we now consider to be faulty inferences from what we learn. And once we take this possibility into account, we're better off knowing less. And when it comes to these real life cases, I actually find the modesty-based explanation more convincing than alternative explanations that appeal to something like, oh, we're not using expected utility theory, but some other decision theory. I think that somehow feels less like the right explanation. But there's definitely more to be said here. So I'm very curious about questions on this slide. All right, cool. Basically, I'm done. So modesty, once we admit it, yields a better Bayesian decision theory, both normatively and descriptively. So there's good decision theory which says that information is always good, but our modest Bayesian decision theory is actually better than good. Sorry, I had to say that. Okay, here's the second thing we should conclude. So we have to let go of value of learning, even if we like all the things that are standardly thought to go into it, even if we like expected utility maximization, we like sharp credences, we like partitional information, I think it's still false. All right, I think that's basically it. So I'm curious what people will ask about.
Great, let's start.